Hi, everyone. Thanks for joining us today at this engineering getting started session. We'll just give everyone a couple more seconds just to come through because we have quite a few people registered today. So people might still be joining. So we'll give them a couple of seconds. Okay, so it looks like the numbers are starting to trickle, so we may just kick off. Before we begin, I just want to say thanks to everyone for joining us today. Thanks for coming along. For some of you, this might be one of your first orientation sessions. So I'd just like to say welcome to your Bachelor of Science, welcome to the university. And just to let you know, we have a whole lot of events lined up in the coming week. We have our on-campus expo and welcome happening tomorrow. So if you've registered for those events, we look forward to seeing you on campus. And if you can't make it to campus, we have a whole bunch of online events as well happening on Friday. So head over to the website if you haven't registered already, and just make sure you put your name down for those events because we'd love to see you there. Yep, that's all I had to say. I won't take up any more time today. I'll hand over to Ray and Lionel to take it from here. We hope you enjoy the session.
Thanks, Charmaine. My name is Lionel, and nice to meet you virtually. I am the subject coordinator for the first year subject that you'll be seeing if you're going down an engineering track. It's called Engineering, Technology, and Society. So today we'll be talking about a brief overview of what the subject involves. I'm going to show you a little bit of Canvas as well. And with me here today is Ray Dagastine, who used to coordinate in the past and will also be lecturing to the subject. Ray, you want to say hi?
Hello, there's a lot happening this week, not just this, but tomorrow ought to be really exciting with the in-person expo. There's a lot going on this week, so it's pretty exciting, Lionel.
Yeah, I'm really looking forward to the rest of the week. Yeah. All right, so I'm gonna jump straight in. Ray, if I miss out anything, just feel free to interrupt me, and yeah, let's go. Right, so engineering, technology, and society. So this subject is a first year subject, probably the first subject you'll see if you're going down an engineering track. The main aim of the subject is to introduce students to the world of engineering and the role that we as engineers play in developing and using various technologies to solve challenges that society faces. We divided the subject into 4 separate modules, and it's sort of structured around this semester-long design project where you work in teams on a real-world design project. And what is this design problem? Well, we want to design a renewable water pumping system in order to deliver safe drinking water to a remote community. So we're going to go a little bit into a little bit more detail on the design project in a little bit. But before we do that, I just want to introduce you to the staff. So as you can see, there's me. So I am the subject coordinator for this subject this year. There's Ray, who's said hello, and there's also Huey Chan, who's not here today, but she's a very important person in the subject. She will be coordinating all the workshops for the subject. If you would like to find out more about us, our contact information and just some miscellaneous information on us and our interests are on Canvas. So you just go to Canvas, modules, welcome, staff information. This might be a little bit what is going on at this point in time, but I'll show you later when I move over to Canvas. I'll show you where to find this information. Right, everything about the subject is on Canvas. All right, so moving on, what are we going to learn about in this subject? So the first thing you're going to learn about is the engineering profession and how to be a professional engineer. So we're going to be talking about the different disciplines of engineering and how they need to work together in order to solve a complex engineering problem. What do engineers do, for example? So this subject caters to quite a few flavors of engineering. We'll get to this in a little bit, but the 4 modules of the subject briefly align with fluid mechanics, which is relevant to mechanical engineers, chemical engineers, environmental engineers, civil engineers, biomedical engineers, lots of different kinds of engineers. The second part of the project involves water treatment. This is relevant to chemical and environmental engineers mainly. And the third part of the project involves image processing and developing this image monitoring system. So this is relevant to electrical engineers, mechatronics, biomedical engineers, just to name a few. And the last module is just, professionalism, and that's relevant to all engineers, but more on that later. You will learn technical skills, numerical modeling, data gathering, data analysis. Most of this will be done in a software called MATLAB. You will learn how to do basic programming. For those of you who have done programming before, good. For those of you who haven't done programming before, this might be a little bit scary, but you just keep up with the work and you'll be able to pick it up easily enough. There'll be fluid mechanics, like I mentioned before. It's basically the physics of how fluids flow. There will be a chance for you to design your own pump impeller using Fusion 360, I believe. That's what CAD is, computer aided design. You will have a chance to 3D print this impeller. You will learn about how to use membranes for water treatment and disinfection, and you will learn how to sort of set up an algorithm, sort of software programming, this algorithm for online sensing and real-time image analysis. And of course, you will pick up these enabling core skills of communication, teamwork, problem solving, and project planning. And it's very important not to underestimate the importance of these skills because they are very important for any practicing engineer. The focus of this subject is a design project, like I said before, and this is a picture of the design project. Again, we want to design a renewable drinking water pumping system for a remote community. This is what it looks like. I'm going to turn on that laser. So you've got a water storage tank. You've got to pump water from this water storage tank to this water tower. But along the way, you've got to make sure that this water is safe to drink. So we're going to use a molecule called ozone to do this disinfection. And we're going to introduce that ozone through this membrane unit. So this is where that water disinfection part of the subject comes into play. You don't want to clog up your membrane unit with like dirt and particles. So before that, you need to set up a particle filter to get rid of all that dirt and particles. And in order to make sure that you've properly gotten rid of all those particles, we have this IIM over here, this image monitoring system to just monitor the water to make sure that it really is clear of any particles. And from the water tower, you also got to design this distribution system to take the water from the water tower to the town, the community, right? So there's a lot going on here, and this is where this systems view that engineers are so known for comes into play. So we don't design the entire system in one fell swoop. We sort of divide this complex system into small subsystems which are interlinked. So we design in subsystems, right? So the first subsystem that we got to design for is this pump subsystem over here. There's also this distribution subsystem after the water tower that we have to design as well. This is where all this fluid mechanics comes in. You're gonna learn a lot about fluid mechanics, how fluid flows, and how to design pumps with Ray. And there's another subsystem over here, this membrane unit. You gotta learn how to design it and how to introduce the appropriate amount of ozone into the system in order to disinfect the water. So this is the water treatment subsystem. And of course, there's that IIM, which stands for Inline Image Monitoring subsystem. So this is where you will learn how to set up the algorithm to process the images that are captured by the camera in real time to make sure that particles do not enter your membrane and destroy it, right? So those are the four main subsystems of the design project. And you will sort of design them sort of in isolation and then learn how to like bring them all together as one big project. Ray, do you have anything to say about this? Did I miss anything? Or?
No, I think when people hear of water purification, I think one of the things we don't realize is as engineers, regardless of the type of engineering we're asked to, only about a third of the planet doesn't have access to potable, safe drinking water. And this has incredible follow-ons into people's quality of life and health. And as engineers, we're asked to solve these problems. And what's exciting about this project is our chance to start to understand this project and then understand the types of technology that we might actually use today or tomorrow. That, you look at this project and you think we're using ozone to disinfect water and we're pumping things around, but really we're also going to be talking about automation and sensors and things that 20 years ago you would have never involved here. So you know, it's that integration in technology into solving these problems that gets pretty exciting. Sorry, I was enjoying answering questions in the chat.
All right, thanks, Ray. So yeah, hopefully this gets you excited. It's a real world design problem, as Ray said, and involves a lot of new technologies. Moving on to some admin stuff, this is what the subject looks like. This is the subject schedule, tentative subject schedule. We sort of divided the subject into 4 pieces. In yellow, we have, lectures which are relevant to engineering, engineers and society. That's that professionalism module. In blue, we have lectures on pumps and pipe flow. That's the fluid mechanics flavor. This will be taken by Ray. In orange, those will be the lectures content on water treatment using membranes. I will be taking that. And in green, we have the lectures on image processing and online sensing, and I will be taking that as well in the later half of the semester. So there is a question on workshops in the Q&A. Yes, we have workshops for this subject. They run every week, starting in week 2. There are no workshops in week 1. The workshops pretty much use content from the previous week's lectures, so you have a chance to apply what you've learned in your workshops each week. And attendance and participation are mandatory. Moving on to the lecture schedule. So we have 3 lectures a week, but because of the large size of the class, we have 2 streams. So on Tuesday, we have lecture 1, 10 to 11, 11 to 12. On Thursday, we have lecture 2, and on Friday, we have lecture 3. And these are the venues. They're mostly in the medical building, medical C403, which is the Wright Theater, or medical C216, which is the Sunderland Theater. On Tuesday morning, we also have 1 lecture in Peter Hall. All right, so once you come onto campus, you'll have a chance to explore and find these lecture theaters if you're unsure. So with that, I think I'll pass over to Ray to talk about, talk a little bit about what engineering is. So I'll assign Ray flight control privileges, and Ray, take it away.
Okay, I should take myself off mute. So thank you, Lionel. Let's see if that works. Cool. So one of the things that if we were all in person at this point, I would say is raise your hand if you had chemistry subjects in high school, or math, or physics, or English, because hopefully everybody had English. But if I then say, raise your hand and say, who had an engineering subject? Most people in the room wouldn't. And so I'm really excited that you're here today because you think, hey, engineering might be more interesting. And so one of the things we're really going to discuss is our role as engineers is what we do in our impact in society, how we relate to society. My hypothesis, which I will push through the whole subject, is that engineers are the engine that keeps society going. We have to solve an amazing amount of problems, and we're doing it for the good of society and other people in general. We're going to talk about what unites us as engineers as well. And so we're going to talk about how we solve problems, because that's probably our ability to do systems thinking and solving problems, regardless of whether or not you're a chemical engineer or mechanical engineer. How we solve problems is surprisingly similar. Now, that might be where some of the similarities stop. My electrical engineering colleagues, when they say design, they often mean design an electrical device. When I say design, I mean design a whole chemical plant. So even there are obviously differences too, and we'll talk about those as well. We're going to talk about communication skills, but we're not going to. Well, actually, I take that back. We are going to talk about presentation skills, but I promise it'll be entertaining. But it's really because we're going to make you be writing a report, and we're going to make you give a presentation about your project. So the things you're actually doing and focused on the subject, different ways to communicate that. Because sometimes you might find, wow, I really enjoyed the presentation, maybe, and somebody's going, no, I really enjoy the technical report. So it's a chance for people to work with that content and communicate it in different ways. And the other thing we're going to really start working on is teamwork. Because, well, I'm sure there's a lot of you who have played sports teams, which is one great example of working in a team. I would take a guess that not many of you have worked in involved projects as teams and technical groups or on technical problems. And this is something engineers do. And sometimes students get a little uncomfortable about that. I'm here to learn. I'm here to learn on my own. Why do I have to work with others? Well, the short answer is there is no engineered device in your life that was designed by one person nor one type of engineer. And to be honest, there are very many devices in my lives that I do not want to use or be in if only one person designed it and no one checked the math. This includes elevators, cars, using computers, and airplanes, as well as, I don't know, buildings, bridges. I'd like a couple people to have worked on that problem together, because as it turns out, you can achieve more as a group as well. And so we'll talk about different ways to work in teams, just simply because that's an expectation of engineers in general. And we'll be a little limited. We're going to talk about how other engineers work together. If you're working in a professional setting, you'd also talk about how you work with business people, commercial people, marketing people, and people from a lot of different backgrounds. We're just going to make you work with other engineers. Now, to give you an idea of the different disciplines, which we will cover some of, I grabbed cool pictures. And while the kind of bionic person, maybe X-ray of a Terminator is possibly my favorite picture, one of my favorite, and the one over on the lower left is a chemical engineering plant. And the one in the middle is what my electrical engineers hate, that picture, because it's just a power station. And they're like, electrical engineering is so much more. But the awesome picture here, I mean, aside from they really are putting it, that's how they put a 747 together in big pieces, and they put it in a very large oven. But it's the picture in the middle of that bridge that fell down. That's good engineering. And people are like, how is it good engineering? The bridge fell down. Exactly, it fell down. It fell down exactly the way it was meant to in an earthquake, exactly where it was supposed to cause the least amount of damage and the least risk to other people. Sometimes it's not about building it so it'll stand up. It's about building it so if it ever falls down, it falls down the right way. And that's good engineering. Okay, so we'll talk a little bit about the different disciplines, but as we mentioned, we've got other topics here. Now, we have a design project, and we don't have any prereqs for this subject other than getting in the Bachelor of Science, and that's all we need. But we've mentioned water treatment and pipe flow, and you're like, what is pipe flow? I mean, that sounds like you're a plumber. Well, I mean, plumbing is important, but we're designing a fluid flow. We're talking about a pump. And so we want you to tackle a real world problem, and we want to make it as much like the real world as we can, given you guys have just finished high school. So there's a balance there about how complex we make it versus how tractable we make it for you. And we try to find that balance. But one of the things we've realized is we want to teach you bits of physics and engineering and different parts of science, but instead of an entire subject on fluid mechanics, which, all right, I'm sure the people teaching fluid mechanics will say it's exciting, but there are ups and downs in it. Some parts I like more than others. We're going to teach you the bits you need for solving this problem. Now, it doesn't mean we're going to cover everything about these aspects, but we're going to cover the bits you need for this problem. It's not that like we're going to talk about pump and pipe flow like it's a movie trailer where, you get the highlights and you can kind of figure it out. No, we're going to actually take the bit we need. And the same is true for water treatment. I don't want you to be an expert on membranes, but I want you to understand how we can make water safe chemically using ozone. And we're going to use a membrane to do that. And then in the last part, we want to talk a little bit about how we monitor and keep water clean. And there's a lot of different ways to do it. And the one we've picked is cool because it's an online sensing program. It also involves image processing. And we're using a camera. So you'll learn a little bit about sensors, but you'll also kind of learn how your mobile phone is able to draw bunny ears on your face as a filter as well. And at least from the last time I saw that lecture, Lionel was kind enough to use my face for the bunny ears. But maybe that's still not true. So we're going to take these pieces together and we're going to teach you them just in time for when you need them. But when I say just in time for when you need them, that's because the engine of our class is not the lectures. As much as Lionel and I are passionate about talking to you about lectures, and as much as we've even got some other people, practicing engineers or experts in different fields that are going to come talk to you about different topics of engineering, the thing, oops, wrong arrow key. The thing that drives our subject is the design problem, and it's in your 3-hour workshop, which start in week 2. Your 3-hour workshops that you'll have about 10 of them are the engine that drive the subject. It is your chance to You will work in teams of 4, not right away. The first one's kind of getting to know people. There are preparation activities. You're going to do written work, experimental work. Some of it's going to feel like a tutorial where you get a chance to work on problems that might relate to homework. And then some of it's going to be testing and measuring and building, and then breaking, and then even writing up design solutions. But the workshops are where the magic happens for this subject, undoubtedly. Your team's going to actually deliver things. It could be calculations, tables, plots, measurements. And the workshop makes up a lot of your mark, as does the project. And so it's a chance. It's very different than, say, your science subjects, which are, we'll lecture at you, do a lab, lecture at you, do a lab, lecture at you, do a lab. That's not our intent here. It's really about providing you in bits and pieces the knowledge you need to work on your project, and that happens in the workshops, which also makes the workshops mandatory attendance, but also a lot more fun. And as I said, workshops start in week 2. So we just have lecture next week, and the week after will be our first workshop. Well, you start to meet people, and there's some fun icebreakers. Oh, and I hope this year, because we're in person, we're going to use the hula hoop sometimes this semester. You'll have to wait and see on that. Now, one of the things we're going to do is we want to actually do some real engineering testing. So in the aspects of flow, we actually want to measure the pressure changes that occur when we put water through a valve, which is this thing down in this little black handle just below the big 2 dials. And this is our fluid circulation rig. And over in the little back, there's a little gray thing that's actually a pump. And it's instrumented with industrial rated pressure gauges. There's a mass flow meter that's kind of hidden on the side. And this is actually what you're going to work with to do measurements. And for that pump, you're not just going to measure the performance of that pump, which is one of the things we're going to do. You're then going to print your own pump impellers, design and 3D print your own pump impellers, and test them on here. So we're going to actually look at different parts of the design solution for that remote community water treatment system. And in a bench scale, we're going to actually test those things and use those results to help us design the full solution. Now, that is our rig, which you're going to be working on your workshops. Then halfway through, we're going to rip it apart, and then we're actually going to put a camera with an observation chamber on it. And this is to observe contamination. And then we're going to add contaminants. And you're actually going to train that camera to identify when the contamination level gets too big and the water becomes unsafe to drink. And so in the meantime, we're also going to learn how online sensing works and a little bit about image processing. And again, these are not tinker toys. This is a high-speed camera, reasonably instrumented. These are the same valves and pressure readings and pressure gauges and mass flow meters you'd encounter in industry and use as well. So this is really hands-on. Now, our workshops, as I said, they start in week 2. So next week, no workshop. I know I'm being a little over animated about that and perhaps cheesy, but I've seen it in the chat at least twice already. So no workshops next week. Our first workshop is in week 2. Now, when the first workshop, interestingly, is actually going to be online for all of us. And Dr. Lionel Lam will take you through in a second some of the things about Canvas and where to find those links. But everybody's going to be online the first week for their workshops. Just because you're still trying to get used to campus, there's a lot going on. Workshop 3 is going to be face-to-face. Now, there's still some people that are offshore, so they're going to be dialing in and taking it online, and we'll get to how that's going to work in a second, but at the same time. So some of our workshops are going to be face-to-face, some are going to be online. Anytime we're testing something, measuring something, or breaking something, although you're going to get water on the floor at some point. Don't worry about the carpet. I've stopped worrying about it years ago. But anytime you're testing something or you're measuring something, those are obviously going to be face-to-face workshops, and you are there. But the consultation times, the team activities, and some discussions, well, we're going to work in breakout groups, and those will be, you still have to come to those workshops. Those will actually be online based to make it a little bit easier for your schedule as well. So workshops start in week 2. You can find lots of information on Canvas and modules. And what you can also find there is each workshop has preparation activities. A workshop is a 3-hour event. It's a big deal. If we're asking you to spend 3 hours of your time, we want you prepared. We want you to have read material. And actually, there's these awesome interactive pages in Canvas now, which have pre-workshop problems, which are part of your assessment. So you have to gear up for your workshop, get prepared, and then get the most out of that 3 hours working with your team. Um, now, some of you are going, I'm online, some people are in person. How's that going to work? Well, our workshops are structured. Part A, remember it's 3 hours. What, are we going to do the same thing for 3 hours? No, in fact, part A is actually going to feel a little bit more. It's roughly the first hour. It's group activities, but they're tutorial style problems. So this might be working through problems based out of just the lectures, this material we had in lecture, and it would be the things that might connect to, say, your homework marks, or be like your homework problems. And then, and it's relevant because those are then the topics you'll be working on for that part of the project. Part B is your time with your team, you're taking data, making an interactive video, you're doing experimental work on the rig, you're doing project-related tasks, and there's a lot of structure there. We don't just say, there's the rig, try not to break it. No, we actually say, gosh, this is what we accomplished today, these are the goals, here's the outcomes we're hoping to see, maybe here's some directions on it, maybe you want to plan your time to get the most out of this time. And so there's a structure provided, and then there's deliverables that are going to be assessed in the class. So if you have to be there, you have to be present, and you have to be engaged. And somebody's going, I'm overseas, I'm offshore, how am I going to be present and be engaged? Well, we've thought about that too. So the part A, we're going to do kind of as like a Zoom breakout room tutorial, but part B, you're a team, and not all of your team may be in person. Some of your team's going to be maybe online, and you guys are going to work together. Because one of the things that happens in teams as engineers is we often have different roles. We might have a team leader. Sometimes a team of 4, you may or may not need a team leader. You could have a design engineer, a data engineer, a measurement engineer. And so we're going to take those roles seriously, and we're going to make the people there in person measurement engineers, and we're going to make the people online data engineers. And so somebody's going to be measuring the reading a pressure gauge, but the plotting and the deliverable that you might have to put out for that workshop is going to be done by the data engineer. So you guys are going to have to communicate. Now, you might bring headphones, you might have to use sign language. I am, by the way, the little flags there, I am all for it. If anybody wants to do semaphore and bring the flags in and stand in front of a camera to your group mate, by all means do that. If nobody knows what I'm talking about, Google semaphore, then you understand. But you're going to have to communicate and work together. And you know what? We did this last year and it was chaotic, but everybody told us it was way better than doing things all online. So I think it'll be fun, even if it's a little loud. It's nice to get a little loud. All our workshops happen in old engineering. That's a very large building. To be peculiar, I made it a very small photo. And in the engineering design studio too. But remember, workshops don't start till week 2, so we'll have plenty of time to cover that next week in lecture. Now, somebody's going, there was a lot of information here. How am I going to keep track of it all? Well, as it turns out, our Canvas page, which is going to go live tomorrow, because I was bragging about it in the chat, is the most awesome Canvas page in terms of resources and interactivity. And so Lionel, I think, is going to take us through a little bit of the Canvas page to show people what to expect and where to find things.
Yep, thanks, Ray. So I'll just switch over to Google Chrome for a little bit. Hopefully you can see that. Yep. So actually, why don't we just start from scratch? So let's say you don't know how to get Canvas. Canvas.lms.unimelt.edu.au. You'll be bookmarking that. You'll be using it a lot during your time here. You'll be able to see all your subjects. You won't be able to see ETS yet, because like Ray said, I haven't published it, but it should go live sometime tomorrow. I'm just cleaning it up a little bit more. So this is what it should look like. So click on the subject, and this is the home page of the subject. Just a brief introduction. I've added this scrollable timeline, which you can like sort of scroll through to see what's due every week for the 12 weeks of semester. So you help you keep track of what you need to submit. But most of the interesting information is in modules. Actually, maybe we'll go to subject overview first. So subject overview is basically just an overview of the subject. There's a short video there which Huey and I put together that describes the project and the various subsystems. So you can watch that tomorrow when the subject goes live. It's internet learning outcomes, and these are quick links to the the important parts of the subject that you need information on. There's information on the syllabus, so you can just click on that I like to think of a syllabus as a contract between us and you as students. So it just contains all the information, who are the lecturers, demonstrators, when are the lectures, workshops. And if you scroll down, there's some information on the assessment structure and the lecture schedule as well, subject schedule, sorry. There's information on staff. So if you click that, you'll be able to read a little bit about me, Ray, and Huey, and it has a list of the demonstrators as well. We go back. Subject communication, assessment overview, an overview of the workshops, and remote teaching. So maybe we'll spend a little bit of time on the remote teaching. So you might be wondering how lectures are going to be running this year. So this is the first time in 2-ish years, 1.5-ish years that we're actually returning back on campus for lectures. So Ray and I, you'll be seeing Ray and I in the lecture theater if you're coming onto campus. But for those of our students who are taking the subject online, you'll be able to live stream the lecture through the lecture capture system. So on the side here, there's a lot of things going on actually. Just let me go to student view. So I'll show you what it looks like for you guys as students. It's a lot less messy, right? So you only have that. So you just have to click lecture capture and you'll be able to, okay, there's an error there. It's probably because the subject hasn't been activated yet. So just let me get out of that, right? So you should be able to see something that looks like this. It's a whole list of all the lectures that are running throughout the semester. When March 1st, 2022 comes, 10:05, this live button will go green. So those of you who are taking the subject online, you should be able to click that green button and live stream the lecture as it happens in a lecture theater. For those of you in the lecture theater, you will be in the lecture theater, right? And after each lecture, a recording of the lecture will be uploaded and you should be able to access it by clicking this button over here. It will become green or blue, right? So all lectures are recorded. So, so that's the subject overview. There's another way to access all the information. On Canvas, information is linked to in multiple ways. You can click modules, and as you can see, you have all these pages set up over here. There's student support services and how to use Canvas and lecture capture. There's a list of engineering student clubs, so I'll just show you that as well. I think there was a question on student clubs in the Q&A before. There's a range of engineering student clubs, so we're gonna have them come in week 2 to talk to you as a showcase. But this table summarizes all their contact details and any interesting websites that they may have. Going back, this module over here contains all the important subject information. It's basically the same thing I linked to from subject overview. So there's the syllabus, staff information, subject communication, assessment overview, workshop overview, and remote teaching, and so on. And if you continue scrolling down, we set up the subject to, we set up modules that sort of align with the weeks of the semester. So in week 1, you'll have 3 lectures, and this will be your workshop content. There's no real workshops in week 1, you just got to install MATLAB. And in week 2, again, week 2 lectures, the workshops start properly. So you have workshops here, and you'll have tasks. So everything has been set up pretty nicely. You'll actually have your first homework as well in week 2. And so on, week 3, week 4, up to week 12, right? So that's what Canvas looks like. It's a little bit overwhelming at first, but once you have access to it tomorrow, I encourage you to have a click around, all right? Ray, did I miss anything out? Anything you want to add? No?
No, sorry. Someone had asked me if you could still enroll. No, I don't think you missed anything. You could still enroll in ETS, and the answer is absolutely. You can enroll in ETS and change subjects up until week 2 in the semester. If someone asked also, is the group work the only assessed work in the semester? And the answer is no. We have a combination of group work and individual assessment. So the group work's about half of your assessment, and individual assessment in the form of doing your preparation work for your workshops, homework assignments, and like this nice big homework assignment at the end that kind of pulls all your things together in MATLAB. Actually, that one's in MATLAB, but we have online homework assignments that are calculation or even some multiple choice. So there's a range of individual assessment as well. We have an individual quiz at one. It's only like 25 questions and it's multiple choice in and maybe numerical, like single number answers. We'll also do that in the semester as well. So your homework isn't dependent on group work. It's split about 50-50. And so I'm going to assume I've answered that one. Sorry.
Yeah. And Benjamin is asking, do we have to do all the modules before we start? No, you go week by week. So week 1, there'll be tasks, complete that, and you go week by week, Benjamin. So I've answered that.
Someone asked, approximately speaking, how much time week by week are we expected to dedicate per subject? So that's a great question. I think one thing to think about there is in high school, what we do in a semester at university in terms of content is what you did in an entire year in high school. So if you think about, you've got 4 subjects and it's a quarter of the time you would have spent in high school in a year, that kind of says, oh, this is kind of like a full-time job, and that's okay. But for this subject in particular, we've got 3 hours of lecture and a 3-hour workshop. And so the workshop, if you took a science subject, you'd have 3 hours of lecture, and then you'd have a laboratory or practical, which might be a couple hours as well. We, of course, don't have workshops every week, and we are conscious of that. And we also are conscious of, we don't even use all the lectures necessarily, just to make sure that overall it's not too much work. But, because we do so much in our workshops, depending on the week, could be the 5 hours of workshop, it could be another 5 working outside of it. The general guideline is for every contact hour you have, you're looking at 1 to 2 hours of revision at university for every subject. So in a bachelor's. Now, because our workshops are so interactive, maybe the lectures have that revision, but you might not have that revision in the workshops. But it'll come in globs. You might have to work a little bit more for your video presentation and then your report. Now, we did something important on our report. We have split it up. We actually give you credit for writing a draft report, which we mark and give back to you well before your final report. So you kind of write 2/3 of your report ahead of time. It gets marked, it gets feedback, and then we do the full report. And we've done that with students simply to help them manage their workload, because this subject isn't that much work if you do it every day. So the real way to succeed in this subject is participation, to be engaged every week and don't let things pile up, and the workload's pretty manageable. Because we, of course, don't have an exam in this subject.
I think what you just said, Ray, it's universal for university. I think as long as you keep up the work across all your subjects, you should be fine.
Right.
So I'm going to give you privileges again, Ray, because you're going to be talking about EMD. So.
Okay. So, and we've had some questions about this, so I'm excited to talk about this. So, engineering, technology, and society is part of what we do in first year to expose you to engineering. But there's more. There's a second semester subject. So just like there's Chem 1 and Chem 2 and Physics 1 and Physics 2 and Bio 1 and Biology 2 and Psychology 1 and Psychology 2 and Maths 1 and Maths 2, there's an Engineering 1 and an Engineering 2. Now, we're a little more forgiving about our prereqs because we know you've got a lot going on. But generally, we say the most fun and the best way to get prepared for engineering is to not just take ETS, but also look at EMD, engineering modeling and design. So that subject is in second semester. And we kind of look at our first year engineering. ETS plus EMD equals engineering. And I know if you looked at that normally, you'd be like, we can't spell. But it actually means that it's these two subjects together that help get you engaged to engineering. And they're split up a little differently. The first one, we talk about how technology is helping solve problems. And we actually try to make some pretty strong connections to society and how to use fabrication tools. We're going to do some design and testing for an engineered solution. In EMD, it's structured a little differently. You have kind of 2 or 3 weeks that are general, and then you break off into these streams where you could be in one of 3 streams. And by the way, you could be in one of 3 streams. That there's, about the same number of students. There's a certain number of slots. So you're going to have a first choice and a second choice. If you go, well, I have to do the robot project, you might not. You can end up designing a speaker or looking at coastal flooding. But in that one as well, it's trying to show you a different way or engineering problems in a different light. Bit more variety in the problem. Not everyone's doing the same problem. and maybe you're drilling down in a little bit more detail. So how we gave just-in-time modules for fluid mechanics and water and membranes and image processing, where we covered a range of topics because we wanted to expose people to lots of different parts of engineering. These will be a little bit more focused. And you're going to get a bit more of a complicated design challenge, and the style of the delivery is a little bit different too. But at the same time, the ideas of teamwork, communication, understanding how to use software to solve technical problems, CAD design, looking at design problems is a unifying set of skills that comes across the subject. And when you invest in yourself in ETS in semester 1, it really makes EMD a lot more exciting, because then you're not shocked to go, I have to work into a team. I need to know how to do that. Or what is this thing we call MATLAB, or how to use CAD software, that you've actually already up on those skills. And the more time you put in this subject, the more you can get out of EMD. And we couldn't come up with good names. I thought engineering, technology, and society rocked. I don't know if engineering, modeling, and design is quite as exciting. So they have pictures of, I think that's the robot. It's an autonomous robot you have to program to pick stuff up and drop it. And like you have to parallel park it. It's not as easy as it sounds. The other one is design and build an audio speaker, and it's of your own, but there you're going to be doing some soldering, but you're doing 3D printing for a lot of the housing. So the CAD skills you get in ETS can really help there. And this other one is modeling and simulate a coastal flooding scenario. So this is using state-of-the-art software about flooding a city, and then you have to figure out where would you put your resources, like where would you put sandbags to protect which parts of the city. And then there's like this 3D printed test chamber where you have to put the 3D printed sandbags and then see if the city floods, and if you actually plan properly, or you forgot one neighborhood and suddenly the whole thing floods. So these are pretty cool things when you do the demoing in week 12 there. And so EMG is 10006, or sorry, EMD, and how they do the individual assessments a little different. There are skills modules that you can enroll in, and which one you take might depend on what project or interest. But if you take our subject, you probably won't need the MATLAB skills module. You may or may not even need the CAD one, but the Arduino or the analog electronics. And you'll also make videos and do report writing and work in teams in EMD, and that's a real core of their assessment as well. So that's very similar to ETS. Now, that's about where we sit on those things. There were a couple more things I want to cover. One of them, it's sort of bookkeeping, but a couple of people said, what student clubs are going on? What's going on in first year? So there's a lot of announcements that come around, and while we'll funnel some of them through this subject, like the student clubs will email us every week and say, hey, we got this going on, and we'll put it in what's called our weekly mailbag. There's like a section on student clubs. There's this trivia night, or this night where they're talking to industry or something. But there's a lot going on in engineering. And because you might be interested in engineering, but you're a Bachelor of Science student, there's a whole faculty of engineering. One way just to hear what's going on, or you could look at it as to hear about all the free barbecues. You can look at it that way too. There's an engineering and IT community you can join in Canvas. And this will actually, it'll start telling you, it kind of puts out all the activities that engineering is doing, or the faculty of engineering is doing. And a lot of this is about industry engagement. Some of it might not be relevant to you now, but you might hear about the internship subjects in the masters where you're actually working at companies. And it's, if you want to get that flavor for what engineering is going to be like, there's a lot of information that you can just, it won't fill your email box, but you can join the community and check in on it and look what are going on with the announcements. Now, the last thing I want to do before we just basically field questions is, we've talked a lot about how in ETS and EMD, we've talked about fabrication an awful lot. So how are we going to do that? We're going to use 3D printing. We're going to use design. But what we're doing gets you connected to something where it's just the tip of the iceberg. And this is the Telstra Creator Space. You didn't happen to actually, hey, Lionel, can I switch screens with you?
Yeah, sure. I'm going to stop sharing. Yeah, there we go.
Thanks. And if I do this right, and then do,
I like how you were talking about the robot and EMD parallel parking that robot. Some of us have trouble parallel parking in real life. So
Yeah, that one's not easy, and you really do have to parallel park it. And if you miss, you like knock something over that's loud and makes you feel embarrassed. But so the Telstra Creator Space is something the university, where engineering had a very large role in helping define it and design it, is a space for students to trial and go build things. And so this creator space, well, named after Telstra, you can guess who helped donate some of the support for it, is accessible. It's a fabrication lab at Melbourne Uni. It's located in Melbourne Connect, which is in the corner of Swanston and Grattan. It's that really tall building just on the other side of Swanston, just past the tram stop. And the whole point is, we know that engineers and students interested in engineering are a group of people that are creative. And sometimes we've got subjects that can just engage you and think about, what if you build this? What if you build that? And we're getting you to build things. But some people go, hey, I wonder if I could try building this. What if I wanted to build that? You know what, we're doing 3D printing, but really, I need a laser cutter, or I need a soldering iron, or I need woodworking tools or metal shop tools. I'd like to try go build something on my own. Well, the Telstra Creator Space isn't just where you're going to come back again and again in your engineering subjects for fabrication and design and testing, but it's something that you can take advantage of as students. And what's amazing about this space is it has a huge professional staff that provide face-to-face training and on-site support. And we're talking industrial professionals, people that have worked in building things in fabrication and industry. So this is a very unique space within universities in general. As I mentioned, it's at Melbourne Connect. You go in over on the Swanston side. What if we turn things upside down? You can see the Telstra Creator Space. It's open from 10.
Sorry to cut in. I don't think you're sharing the right slide deck because we can't see the TCS picture. I think you were sharing your entire screen.
How about now?
Yep, that's good. Thanks.
Cool.
Yep.
So, oh no, that's different.
Oh no.
There we go. So that's the entrance on the corner of Swanson Street. Melbourne Connects this really tall building. Actually, a lot of engineering lives there as well. So what else is there is the equipment and tools that are there are quite involved. It's 2 floors. We've used the 3D printer maker suite quite a lot. The laser cutters are pretty awesome too. As you can see, there's woodworking, there's an electrical shop, there's metalworking tools. And so if you can think about what you can create and design, this is a place you can go as a student, and it doesn't have to be related to a subject. What you do have to do is think about orientation and training. And so all this week, if you're thinking, oh, I want to come to the expo tomorrow, go to the expo tomorrow, but actually book in an orientation. You could do, there's the space tour, the metal shop, general maker training, and there's actually inductions that are going on all this week, but you can get inducted next week, or you have to just sign up for the inductions and the trainings, but you can actually start to see what that space has and the potential for what you can do. Up here, I think those are laser cut and embossed wooden keychains. And actually, as you go through an engineering degree, this type of skill sets just to really broaden your mind about how you look at design problems, because that ability to have some hands-on component can really change the way you think. There's also a Summerfest stall at UMSU. There's a Summerfest stall on the South Lawn. I think that's tomorrow, or there's a Summerfest thing on Friday as well. So there's quite a lot going on, and I just wanted to, I'm going to stop sharing my screen because it's not working that well. There's quite a lot in the Telstra Creator Space to keep in mind as well. And you'll hear about that again and again. And we're going to talk about an ETS and how to engage with it and ensure you can 3D print on time and things like that. Okay, can you do EMD as an elective in second semester? EMD is offered in second semester. I mean, technically in the Melbourne model, I guess every choice in your first year is an elective. So yes. Is it possible to do EMD or ETS without doing the other subject? So we offer ETS in semester 1 and EMD in semester 2. And we know some students may end up just taking one of them, but it's because we use the Telstra Creator Space at the same time, it's kind of hard to offer them in the same semester. Would modeling and design be difficult without? It'll be different. I wouldn't say difficult, but if you take EMD without ETS, you'll have a different experience. It's not a bad one, it's just a different one. I think if you take ETS, you're more likely to get more out of EMD. But also, if you're interested in engineering, it's time to take engineering subjects. And if you're worried about how am I going to fit this in, because I have a science subject and I have the discovery subject, please remember, you do not have to take 5 or 6 breadth subjects. You can only have to take 4 breadth subjects. The other 2 subjects can be science electives. So there is some freedom in your schedule to mix and match, particularly if you're thinking, oh, I want to be an electrical engineer and I got to take physics subjects, but I also want to take the coding subject. Do that next semester as a breadth subject, because a breadth subject can be a science elective subject. So there's a little bit more flexibility in your schedule than sometimes people realize, because in the bachelor's, they see discovery subject and 5 breadth and think those all have to be breadth subjects. Only 4 have to be breadth subjects. So there is a little bit more room if you're worried on like one, I need to take Chem 1 and Chem 2, and how do I fit all this in? Is ETS a prereq for EMS? Well, it's not a prereq for EMD. I don't know what EMS is. Just kidding. Is software used for CAD on these subjects? Absolutely, and it's free for students. And we're going to show you how to install it. We actually support Fusion 360 or Inventor for our subject, although I am a huge fan of Fusion 360 because it's Autodesk. It's the same company that makes Inventor, but Fusion 360 will work on a Mac, it'll work on a PC, and it also makes your projects cloud-based, so it's brilliant for collaboration. So you can share a project or a drawing or model across a team really easily. I use Fusion 360 for most of my own design work as well, because we make a lot of prototypes for our laboratory, and it is so much easier to work. And it's a little bit more intuitive than, say, Inventor. Lionel, why don't you jump in and grab your favorite question?
Would it be possible to join the Telstra Creator Space programs next semester? Yes, of course. It's going to be running throughout the year. So looking forward to having you on campus next semester. As engineers, do we need to have Windows or can a MacBook run everything? That's a good question. I think early on in your degree, you'll find that you won't have too much problems with a MacBook. But as you progress further in your degree, you'll find that some disciplines have some bespoke software that do not really run that well with Macs. But you can deal with that when the time comes. Ray, do you want to add to that?
Yeah, so there are a couple things. So, so as you get sometimes, for chemical engineering, the chemical engineering simulation software only runs on a PC. And I think that's true for some of the electrical things. I know ZMax only runs on a PC, ComSol runs on a PC or Unix, and some of the Cadence, the electrical engineering modeling software, might only run on a PC. But there's a couple ways around that. You can use Boot Camp on a Mac. You can use VMware and do Windows in a window, and that works just fine. Also, the university is getting better at My Uni Apps, which is a virtual desktop where you can access Uni software. So our computer labs have all of the software working on them that you can need. But if you want to work from the comfort of somewhere else, you can use My Uni Apps. And that's been pretty effective because I know they use that for computational fluid dynamics, because the guy who teaches it is just this Mac lover, but it doesn't run on Macs. So they use the Uni Apps. Sorry about that. I thought my phone was on silent.
Thomas asks, do I need a strong enough laptop to run certain programs? I think you should be fine with a standard laptop. You're not,
one that's strong enough so it won't break when you bend it. Yes. But people use MacBook Airs, they use Surface Pros. Mm-hmm. Those are probably the lightest weight ones. I think MATLAB will run on an iPad.
Wait, will it?
I thought there was an iPad app for
I mean, the kind of computation you're going to be doing, at least in this subject, is not going to be that involved. So you probably don't need such a strong laptop. Yeah. How far can our Telstra Creator Space project go? I want to say as far as your imagination takes you, right? Like there's a workshop staff there who can help you like shape your project and give you advice. So you should make use of them once you get trained.
I think getting trained is part of it. And so how the Telstra Creator Space works is if it gets really busy, there's a booking system. And during the semester, subjects kind of get priorities for like, you know, if they're actually coming in to build for their subject because they're pracs in there. Out of semester, it's a little bit more flexible, but there's a booking system which during semester, if you're not associated with the subject and it's really full, you might have like a 2-week lead time. But, you know, that depends on planning and you know, if you're doing an involved project, you're probably doing it in pieces and stages anyway. If it's like you're doing making a Christmas ornament on the laser cutter, which is one of the induction things they did last year, that might be a little faster.
Salim Azizolu asks, has anyone tried to make a flying suit?
Yeah. Well, so the comment about the discovery subject, science, today's science, tomorrow's world today. So I'll say 2 things about that. There is a module about chemical engineering and vaccines. There is a week about civil engineering in it. So there's at least a little bit of engineering that I know of. But again, if you're taking something this semester that you could actually take in your breadth slot as a science elective next semester, you can always move things around that way if you want to take ETS. I do wonder if they could make the discovery subject a little bit more flexible and just make it your first year. So that would free up taking ETS a little bit. But if you're taking math and a science, you know, the common clash there is people take math, science, a science set, physics or chem, maths, and normally you take ETS and the discovery subject, but you're also trying to take a coding subject. Please remember, if you're taking a coding subject and you're just following the engineering path for mech or chem or elec, you could easily take that coding subject in second semester as a breadth subject because it could be your science elective. So you don't always have to be quite as constrained about that. But also remember, Lionel and myself and one of the lecturers for EMD, Gavin, will be at the expo tomorrow. If you want to ask us these kind of how do I mix and match and make my first year work, please come by to chat to us. And then Gavin and myself will be at the online virtual expo on Friday, so we can help with mix and matching there as well. Don't know about the flying suit. Making a flying suit is fine. The testing is where it gets a little scary.
Sweet. I think we got all the questions. Yeah.
I think so, right on time. So thanks for that, guys. So I think you've already mentioned that you'll be available at the expo to answer any questions tomorrow on campus and also virtually on Friday as well. So wonderful. I think we have one other getting started session happening now. So I think we might have to wrap it up here. So thanks so much, guys. And for those of you who joined us, thanks a lot. And yes, the recording will be available and it will be on the science orientation webpage later. Thank you.
Thank you. Hopefully see you tomorrow.
Yeah. See you tomorrow.